All right. So ADS-B, automatic dependent surveillance broadcast. That's a mouthful. So you might say, well, it's automatic. That's pretty logical. Pilot doesn't have to do anything. It just works. It is a broadcast that is going to be dependent upon surveillance. So much like the transponder, it needs to be painted by a radar before it acts. When it acts, it's going to add to the data stream that we've already talked about. Add more information. Now, in implementation, they realize that this is going to happen over time. There's a mandate. They made a hard mandate, 2020, January 1st, do it or die. Or really do it or don't fly in a Mode C Vail area. Remains to be seen what they do when they suddenly realize that half of the fleet hasn't complied and it's January 1st, 2020. My guess is there'll be some feet shuffling. They'll sort of come along and say, okay, the mandate still exists. Those of you that haven't complied, we're going to create an expedited waiver process that will buy you a year or something like that. Okay? And the reason will be because those that haven't complied will say, I'm ready to buy one right now. Sell me one. And the manufacturers will say, we're building them as fast as we can, but we don't have one yet. The owner operator will then say, then I'm going to fly my airplane. And I don't care about your mandate. If you have a problem with that, then I'll be happy to write my legislator. My first request will be to defund the FAA. Okay, so I mean, that's kind of ugly that we're going to get into, I guess. However, the FAA has also said, and this is fairly reasonable, they said, look, we're going to create a system that has all of the airplanes talking to us, and we should give some information back to the airplanes. So in giving information back to the airplane, we're going to need to build a bunch of ground stations, a bunch of antennas that transmit that information out above and beyond all the radars. So they spent the last, I don't know, 10 years or so putting up a bunch of these antennas. And in fact, if you go online, we could go online and look at, most of the United States has pretty good coverage. There's places in Utah and Wyoming and other places where it's kind of like looking at the Verizon map. You know, there's some gaps. Well, that's true here. Okay. So their ground-based antennas provide ADS-B data that's available. Your airplane can receive that data, so we've called that ADS-B in. ADS-B out is information that your airplane is going to transmit outwards. So because of this sort of bifurcation, even though in a perfect world what we would do is just like the transponder, we'd say, let's make a transceiver. It transmits and receives. It turns out that the ADS-B in data, it's a pretty cheap device. You can actually program a small little microcomputer called either a parallax computer or a Raspberry computer. In fact, you can buy the whole dang thing for 150 bucks. What do we say, 100 or whatever, and build your own unit to receive the data in. Or you can buy a ready-made one. And I've got one. We can play with it when we get in the lab. So what we've ended up with at this point is we have a bunch of hardware units dedicated to ADS-B in and a bunch of hardware units being installed dedicated to ADS-B out. And as this has transitioned and moved forward, those that have developed the ADS-B out technology are now starting to integrate ADS-B in to their technology as well. So at some point we'll reach a point where for those that don't live in the Mode C Vale area, I'll probably be able to buy ADS-B in devices for a long, long time. So I'll be able to get that data, the data that's available, and I don't need the ADS-B out because I don't fly into the area where it's required. Those airplanes that do, they'll be able to buy an ADS-B out device that does both in and out. Okay? As far as I know, there's only a few left that only do ADS-B out, and they're going to quickly catch up. We're talking anywhere from $1,000 up to $4,000 or $5,000, depending on how pricey you want to go, and all the bells and whistles for the component, then the installation cost. Okay, for the ADS-B out technology. We also have a problem of the fact that we've got a transponder that's going to go ping 1262 blank. Well, why throw that away? It works just fine. My new ADS-B component still has to do that. So why can't I make something that's an add-on? That it goes ping 1262 blah 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 blah. Whatever the ADS-B data statement needs to be. So well, that's pretty convenient. That can lower my upgrade costs. But then the question becomes, well, how do I do that? And this is where we're seeing industry do a lot of interesting things, which is causing the FAA to go, we didn't expect that. So a couple of different strategies. One is going to be you take your transponder and you disconnect the antenna, the cable from the antenna, plug it to the ADS-B out unit, plug the cable from the ADS-B out unit back to the transponder antenna. Right? That could be one strategy. Another strategy is one company has developed a device that just clamps on over the coaxial. Once the transponder has sent its message, it then adds its data out the same antenna line. A number of manufacturers, including the one that's in my smaller airplane, they figured out that they really need a separate antenna for ADS-B in and ADS-B out. So the transponder ADS-B out is on one antenna, little stubbies. ADS-B in is on a separate antenna. Another one I'm looking at for my other airplane, that was what was on the website there. I think it doesn't connect to the transponder at all in any way, shape, or form. It has its own separate antenna, and I think the way it works is it waits for the radar paint and then my transponder to ping, and then in that intervening time, it adds its own data message to it. Here's the unique identifier for this airplane. Here's where I am. Here's my vector. Here's all my GPS information, and how many children I have, and how much taxes I paid, and what other information Big Brother wants to know. Who I voted for. Okay. So because of that, the transponder industry has gotten fairly confusing. Right? There's a lot of different potential options. Now let's add some more confusion. Remember this conversation we had about VFR versus IFR? Well, the other thing we didn't talk about as much is experimental. Now, when I talk certified airplane, for the most part, the components I have to install have to be TSO'd. There is no TSO requirement for experimental airplanes, except, and this one's weird, the regulation says no person may operate a transponder, it doesn't matter what it's installed in, unless it meets these specifications. But there's nothing that mandates a TSO for experimental. So there's this weird thing going on where right now the FAA made a change, particularly a significant change with respect to error checking. A company that was diving into this business called NavWorks said, well, we respect that change. Here's the TSO. Our equipment meets all the specifications. The FAA said, we made this change. We don't think it does. And you have to allow us to inspect your facilities and do all this stuff. And they said, well, no, the TSO doesn't give you that kind of authority. They went back and forth and back and forth. Finally, the FAA said, well, we don't care. We're just removing your TSO. We're reneging on it. It's in court, and it'll be in court for a while. And I'm sure the lawyers are all over it. The FAA is going to be interesting to see how this plays out. However, one of the things the FAA had to admit was NavWorks can continue to make their product and install them in experimentals. In fact, they had the same unit on experimental line. And FAA had to publicly admit, yep, that the TSO they're not required. There are no standards for airworthiness in any way, shape, or form for experimental aircraft. Of course, the other part of that is experimental aircraft, they used to be a little bit, they're now a big chunk of the market. Okay, there's a lot of these airplanes out there flying around. So, the world has gotten very complex in a fairly short period of time. And of course, much as I love the FAA, the other problem the FAA has is the same thing I think many of our institutions have, is that their institutional competence is declining. The expertise, their ability to attract qualified professionals to work for them that have a pretty high degree of expertise, it's declining rapidly. Why would you go work for them when you can make a whole lot more working on your own? Okay, particularly if you really know what you're doing. So now you end up with folks that don't really know what they're doing. They're a little thin-skinned about the fact that they don't really know what they're doing. So they're going to have a tendency to bark and say no matter what. It's room for a mess. Okay. Oh yeah. So that's an older map. That's a map that sort of shows. Yeah, East Coast gets everything. West Coast sort of gets left out. Not really, more in the middle. The map is actually relatively accurate. I fly out through all those white areas all the time, and ADS-B does drop out. So they came up with a couple of frequencies. Well, I actually have to back up a little bit. Before ADS-B sort of happened as an idea, sometime before ADS-B really solidified as an idea, we developed Mode S, which is the same concept for airliners. And it really is the airliners providing a whole bunch more data, pretty much the same data set. And they operated in what was called extended squitter mode on a slightly different frequency, rather than, it should be 978, not 987. They've been operating on this extended squitter frequency for quite some time, above 18,000 feet, 1090 ES. So when the FAA came along and they said, we're going to do this, we're going to create, we got another frequency from the FCC, 978. We're going to call that the Universal Access Transmitter frequency. They wanted it to be everything below 18,000 feet would operate on 978, and once you go above 18,000 feet, you got to go click over to the 1090. For a lot of political reasons as well as technological reasons, they have been successfully resisted in that. So the ADS-B system, where we've got broadcasters sending stuff back to you, information, we'll talk about that information, that's transmitting on this universal access frequency. This frequency here is being received by the FAA radar services, and it can also be directly received by any airplane that's receiving on the 1090 frequency. So add a whole nother layer of confusion, because ADS-B in and ADS-B out now is two frequencies. Some have both, some have one, some have the other. As far as I know, all will have the 978. Some don't have the 1090, some do, in terms of receiving in. For those of us that aren't airliners operating below 18,000 feet, having the UAT will meet the mandate. Having the UAT above 18,000 feet for a non-airliner will also meet the mandate currently. The FAA would like to see that not happen. They want to say, whereas where we are right now is if you're an airliner operating above 18,000 feet, you're going to be on the 1090 extended squitter because you've already been on it for quite some time. Okay? So a couple of things you're going to get in the data: aircraft current GPS position. Note I say GPS position. That's not radar position. GPS position. Part of what started the problem between NavWorks and the FAA was, remember this report I told you about that you can go get about each flight you take? Well, the FAA is looking at all that data. And they're looking at the data and they're looking at it and they're saying, okay, well, let's compare it to, we know what the unit is, we know what the airplane is, we know what unit they have installed. These are all components of the data stream. Let's go look at them compared to the radar data. And they looked at NavWorks and say, well, there's some significant mismatch between the radar data and the data you're providing us. You got a problem, and we want to look at you. And we're going to change the standard, and your problem's even worse. Now, of course, think about the logic of this. Didn't we say radar sucked, and we needed to come up with a system that allowed us greater accuracy? So now we're going to go back to something that sucks and say, well, there's an error, therefore the new system with greater accuracy must be wrong, even though we know this sucks. Okay, this is your government at work. And I'm not making this up. This has been documented. Okay, that whole lot of this has been clearly and compellingly documented. That's why, in fact, NavWorks went public. They put on the front of their website this big long letter describing all of the stuff the FAA has done wrong. And it's pretty straightforward. It's like, oh, okay. Wow. Now, I know for some of you, there's probably a little bit of discomfort flying around in an airplane where they've got your IN number. They've got your number. They know where you live. They know who you are. Well, I have to tell you, it might be against the law, but it's pretty easy to program somebody else's number in there. I did it just for giggles to see what would happen. No idea. I just got a report with a different IN number. It didn't know. System has no way of knowing. You know, program back my original one because one of the regs says you can't do that. But I was interesting. I was just trying to see if the system had any way of knowing, and it doesn't. Now my guess is at some point they'll probably come back and say, create part of the standard is that once you've programmed a number in, it can't be changed unless it goes back to the factory. Because they can't say I can't sell it to you and you install it in your airplane. But to get the number changed, you would then have to go back to the mothership or something else. So my guess is at some point that's going to happen. So the information available to you on ADS-B in, we don't have enough acronyms in the world, so we're going to create some more. We're going to have ADS-B TISB and ADS-B in FISB. So Traffic Information System, Flight Information System. So Traffic Information System is going to be position, altitude, and vector Now let's say vector. Vector includes not only direction, but relative velocity, okay, of traffic around you, okay? It will either come directly from another aircraft if they happen to have ADS-B out, or the information that radar surfaces has about all of the air traffic in the area will be transmitted to you from the ADS-B out antenna. Now you say, well, how does it know to transmit to you? Well, the way the system is set up, and this is pretty sophisticated, if I have ADS-B out, I'm telling it who I am and where I am, which way I'm going. It says, okay, based upon that and how fast they're going, we're going to make a block of space. And we're going to send that data out. So if I'm going really fast, we'll make it a little bit bigger. And we're going to offset it a little bit. If I'm going a straight line, I don't need to know a lot about who's behind me. If I'm doing circles, then it'll adjust it, right? But it'll then give me a package of information that's relevant to me. I also need to know too much about people at 38,000 feet. Don't need to know too much about it. However, they're probably on 1090 ES, their extended squitter, so I'm going to get it directly anyways. Okay. Now, what happens is when you look at this on screen, I can tell the difference. When I'm getting direct information, you'll see it creeping along the screen. When it's being provided from radar services, it'll go blip, blip. Again, you can tell there's a function of radar sweep happening in there. Okay. Sometimes it'll go blip and disappear because something got lost, and then blip, it'll appear again. Okay. This is going to be latently behind. So I'm looking for it right there, and I see it blipping. I know it was going that way. Look over here, because it's going to be, 6, 8, 10 seconds off. Whereas the one that's moving along, that's real time. And I mean, you go where it says to go, and there's the plane right there. So that's pretty good. What I've discovered and learned is that every plane that I actually do physically see, as long as it's not an airliner, is typically less than 2 miles away. Sometimes you can see them at 3 miles away if the light's right. But most little airplanes, you can't. They're amazingly hard to see. It took a little bit to get used to. When you got a plane that looks like it's going to be a direct hit, it's going to be really close. Oh my God, it's really close. And you're zooming in and you go, oh my God, it's really close. You're really getting panicked. Well, if I turned the unit off, I wouldn't be quite so upset. And up until I installed this, I didn't know that airplane was there. So you have to sort of train yourself as a pilot to not get too upset about it. You want to see it if you can, but don't freak yourself out either. Otherwise, just in fact, one of the flights the other day, I don't know that we would have had a midair, but it identified an airplane I needed to see, and it was less than half a mile away by the time I found it, but I knew to be looking for it. And when I did find it, like, oh yeah, I need to turn. One of us needs to turn. And both of us need to not turn the same direction. So the second body of information, FIS, Flight Information System, it's going to provide a whole bunch of airport data and weather data and temporary flight restriction data. All very useful information about which the only way I had to get this prior to this system was pull out my iPhone and download it, call up flight services and say, hey, can you give me this information? Scribble, scribble, scribble real fast. Call them on the radio, scribble, scribble, scribble real fast while the plane's doing this. Okay. Now, I don't do anything. Plug in my flight plan, poof, go. Oh, what's the weather over at Hemet? Oh, okay, looks pretty good. Over there in, Brawley, looks pretty good. Over there, Carlsbad, foggy, sucky, we're not going there. Okay, it's all right there on the screen. It also gives sort of blocky, funky radar, NEXRAD radar data. Nothing, anything like what you can find on your iPhone nowadays with typical free apps or your smartphone. But it's still real time while you're in flight. So you don't have to have your cell phone turned on, okay, and you know, flying low by the, you know, the cell phone towers to try and pick it up, right? Okay. I kid you not. I plan when I fly east back toward the east. I plan my route around the rich areas like Aspen and Telluride, etc. Because you know they got a whole bunch of good cell towers there for all those rich people. So as long as I'm flying by there, I get great cell connection, get all kinds of weather data. I'd be flying along. There's a cloud on the screen. There it is right there. I drive around it. Okay. It turns out that the cell phone providers, they'd much rather have you turn it on and have it all work. But the FCC says no. So they say, well, so the FCC says not only no, but you have to prove you're practicing no. So what I figured out, at least for Verizon, is if I'm below about 2,500 feet AGL and I'm going less than about 125 knots, it works just fine. But if I get going too much faster, I get up to 140, 150 knots. Pretty soon, it says I got a great connection, but it just, no data comes. Okay, so they figured out how to triangulate and go, yeah, there's no road up there. He's got to be flying. So we're just going to put him on slow-mo time. I know some of this because one of our, a good friend of mine, also one of our prior graduates, was one of the vice presidents down at Qualcomm, and they had a whole division focused on trying to convince the FAA that it would be a good thing to have to allow cell phones and cell phone use in the air. I strongly suspect the reason the FAA is against it actually has nothing to do with the cell phones. They don't interfere. Nothing in a cell phone and the digital technology would interfere with an airplane. We're long, long past that. But more importantly, if you're in an airplane with 300 people in it, and something's going on and the flight attendant really needs to be in command and get everybody's attention, it isn't going to happen if you're all talking on the cell phone. Okay, just flat isn't going to happen, and that is a safety issue. And so I get why the FAA has been pretty resistant to dealing with that. It's funny, they usually don't push this, but if you're on an airliner and you don't do what a flight attendant says, you can be arrested and thrown in jail right there. And I see people give them lip all the time, and they're usually very nice about it. That whole thing about the guy being drug off back in Chicago, wherever it was, he should have been drug off and arrested. Absolutely, he was directly violating flight attendant, and unfortunately the FAA backed down. They really shouldn't have. He committed a crime. Unfortunately, it wasn't United. Yeah, United actually didn't have anything to do with it. It was some local security service, but the guy actually was breaking the law. So a really, really useful thing. Airport data is useful. Okay? Guess what happens when you're flying along across Lake Superior, like that, going to Menominee, whatever the next state it was. You know, flying along, you go along, you fly along, all of a sudden, listen to the FM radio, and all of a sudden somebody says, hey, guess what? George Bush just landed. You look down on your little map and you realize, oh my God, I'm 31 miles away from there. That's where I'm going. When was George Bush isn't landing there. He just landed. Turn, warning, Will Robinson. Okay? I landed, called up flight service, said, you guys, I just called you an hour ago. Told you where I was going and you didn't tell me anything about this TFR. Well, there's no TFR there. Then how come they just announced on the FM radio that George Bush just landed there? Excuse me, sir, let me go, a while later they came back. Well, I guess you're right. They didn't give us the information. Okay, if I continued on, I could have been shot down. And no matter what, had I continued into that veil, I would have been at fault. Even though they didn't give the weather information to the flight service to give to me. And I had evidence of having done all of it. This is exactly what happened to, what is it, Idaho Senator Idaho from the state of Maine. He was on an IFR flight plan flying into Washington, D.C., and which is permanent TFR. They violated him. They almost shot him down. And he went after him, said, I've done everything by the right, and by the way, I'm a U.S. Senator. So this isn't going to go well for you. Ultimately, what we now have is called the Pilots' Rights Act that changed the medical parameters. But the more significant thing it did is it said, if the government screwed this up, they cannot take action against you. And if they do take action against you, they're liable for it. Fully, completely liable for it. Up until that law was put into effect last year, the government, under the Powers Act, the Patriot Act, had the legal authority to shoot you down without asking any questions, even though they screwed it up.
Amazing.
One hopes that ADS-B is going to help with this. Because now they know who you are, they know you're probably not a bad guy, they can communicate with you a little bit better, etc. So again, this is going to be, we have to pay attention to this. How this is going to play out over time is going to be very interesting. Now, 20 years from now, all the old equipment is going to be sort of gone. It's going to be, everybody's got to upgrade their stuff to whatever's new, right? You guys do it with your phones, right? Your toasters and whatever else. So 20 years from now, everybody's transponder is just going to be that way. I went through all the Mode C changes, and that's happened now. I don't think there's a non-Mode C transponder out there. If there is, I haven't seen it in a while. So there'll be a long period of time there where I think industry is going to be trying to figure out what to do, what we can do. I think you're going to see, for the most part, ADS-B components being separate or having a separate antenna. The exception is going to be the real high-end boxes, like the $5,000 box from Garmin, right? Okay. Right? That's after having paid 3 years ago $3,000 for your previous transponder. Okay. Huge compatibility problem with other components. So ADS-B in, ADS-B out, the transponder, and the GPS data, whether that's direct to it or coming from your GPS system, wide area augmentation, all of that has to be proven to be compatible. And this is fairly new. This is about the last 12 months they've come back and realized, yikes, we're getting a lot of errors because these things don't talk to each other well. So here's a couple of examples of some of a flight I took. And it's a little hard to see. And of course, man, they're using some great values. Let's see, I got my MIC and my NA/CP, NACB, XL, so, whoa, my Lord. Who knows what all that? Well, you can actually go online and download a dictionary, an acronym dictionary for what some of this means. So the difference between those two flights, you'll note so in these values here, it's showing 100% error. I intentionally put a hexadecimal code in that was different than my N number. And it knew that was a mismatch. So it's going to the FAA registry and comparing that. The other one was so these are the number of measurements. It took 3,185 measurements, and it showed an error of on 7 of them. Okay. Well, that was while the airplane was upside down. Okay. I had since gone back through and found one really quick aileron roll doesn't trigger an error. But if I do a slow barrel roll, that'll give me a 1% error, a minimum of a 1% error. Now, again, it'll be very interesting to see what happens, particularly in this integrity and accuracy thing, because they have claimed that once full enforcement happens, any errors here and you're considered out of compliance, yet the law doesn't prohibit you from operating the airplane in a way that might cause the GPS to occasionally kick out an error. It's not my fault that the satellite can't wrap around and talk to me upside down. They should have made their GPS work better. Put a bunch of reflectors on the ground or something, right? All right, so let's talk a little bit about digital communication in general. This has already become the way of the world. If you guys own a car that was made after the year, well, if it has electronic ignition of any kind, or electronic fuel injection of any kind, you're already dealing with digital communication. Okay? What we're seeing now, and this is pretty solid for almost all car manufacturers since about 2002, 2003, is we actually have a whole bunch of serial buses on the car. Okay? My little Honda Fit's an example of that. The wiper switch, the horn, seatbelt restraint system, they all integrate to a common bus, and there are different modules and components that all have unique identifiers. So when I turn on the wipers, that sends a data signal out, and all the modules, control modules, say, nope, not me, nope, not me, not me, not me. Oh yeah, that's for me, that's for me. And I've got a little driver that can turn on the wiper motor. Okay, that's pretty much like the internet, only in the car, right? So totally makes sense. Let's do it. So it turns out there are several different ways, and there's a multitude of different ways of doing that. But ultimately, it's going to be ones and zeros. So I could do several different strategies here where I'm running multiple lines. Here I'm going to do a double blip. I'm going to do a half blip or a complete off blip for my ones and zeros. Here, what I can do is I can do a bottom end blip or a top end blip, telling it that it went to 1 or shifted back to 0. And if there's no shift, it just stays at whatever it was. The key component for both of these is that they both have to be synced. Data value, data value, data value, data value, data value. So they're both have a heartbeat that's happening the same rate. The data value can be high or data value can be low. Or it can remain the same from whatever it was before. The biggest two problems with all of this are, one is being able to transmit enough data over a single line can be kind of difficult. If I just do on, off, on, off, on, off, I can only send one data stream down that line, right? If I use a strategy kind of like this, I could be operating one data stream at 600 hertz, another data stream at 732 hertz, another data stream, okay, and I have a whole bunch of different frequencies on one line, just like your cable TV does, all the different channels. Okay, so I can be operating a whole bunch of different frequencies, like a whole bunch more data online. If I start going to a carrier type signal versus a straight serial binary signal. So we can do some things to improve digital communication. There's one, well, so, uh, yeah, so here's another couple of different strategies. One is showing amplitude. One is showing frequency modulation. A whole variety of different ways of doing it. Obviously, the higher frequency, the more units of data I can transmit over a single period of time, right? So higher might be better. The other problem I've got is, let's say I send you a value of data, blah, 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 blah. And you get it, blah, 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 blah. And there's a little blip in there. How do you know whether or not that blip was meant or not, was intended or not? Could have been, you know, the electron storm farted and poof, the wire somehow got jinked and you got an extra little chunk of, you know, an extra chunk in there. How do you know it's correct or not? So signal or data transmission error checking is very difficult. Well, so one of the things they've done is they've come up with a process that they call checksum, where any package of data, regardless of what value it is of ones and zeros, if you take it through a specific mathematic formula, it will derive a number. And so as long as you include that number at the end of the package. So now remember we said earlier in our protocol who the sender is, who the receiver is, where it fits in the line, and then some error checksum value. The receiver says, okay, I'm going to do that math, that same formula. Did I get the same number? If I didn't, sorry, that's garbage. Throw it out. Send a note back. Resend me that packet. It was garbage. Well, that's okay. If I'm sending 5 gazillion units of package down the pipe per second, that's okay. I got one bad. Wait till we get the next one reset to me. Okay. So and then this talks a little bit about the different packets, some of the different things that can be included. And as you know, most of you know, there's a whole variety of different protocols. The IP or Internet Protocol is the addressing and communication protocol for all Internet transmissions. You guys might have heard POP or POP3, Post Office Protocol. Okay, you might have a whole STMP, Simple Mail Transfer Protocol. One's for receiving email, the other's for sending email. Your various different cell phone providers have come up with protocols that, you know, each one, of course, has their own magic something or other that they say makes them better. So the idea of standardizing is pretty standard, but the standards they come up with aren't anything close to standard. Sorry, it's just the way it is at this point. So then, of course, some other manufacturer comes along and says, well, we've made this cool little whatever it is device, cell phone, and, you know, and it'll work on any one of them. Maybe, maybe not. Sort of does everything badly. So we can start, and we will see this we're already seeing it. Digital networks exist on airliners. Whatever the pilot is seeing with respect to the engine performance and other performance parameters of the aircraft is being data logged and being reported to home base. Okay. Most fleet operators in the ground base, okay, trucks, FedEx, UPS, post office, etc. Their fleets, they're all reporting to home base, real time. This has been going on for a long, long time. My first experience of this was when I did some training in the '96 Olympics back in Atlanta, where the transit depot was whining to to Rolls-Royce that their engines weren't getting the correct mileage. They weren't living up to the mileage performance standard. And of course, the engineers at Rolls-Royce were like, "Well, you're probably driving them too fast." No, my drivers are all they're under the speed limit. Blah blah. So the guy pulls out his laptop and goes, "Okay, well, here's your driver going down Main Street at 65 miles an hour, and it's a 35-mile speed limit." Those guys are like, never mind, right? You know, yeah, that was back in the 90s. So we had this in airline industry, dating all the way back into the 80s, where engine performance stuff was being reported back to home base. It's throughout industry now. This is to our benefit, being able to use this data to help us diagnose what's going on and manage stuff. You know, the exhaust pressure ratios on an engine are reaching a point that engine needs some work. Okay, it's going to make it, overnight in San Diego or Chicago or somewhere else. Okay, we're getting there. Make sure an engine is delivered to there by the time the plane gets to there. Have the crew on staff, and we're going to do an engine change. That airplane is going to fly the very next day because of this cool technology. That's a good deal. That's highly useful. So yeah, here's an example of this is Larry's airplane. I don't know why in 24,000. Okay. So you got a whole bunch. Four of these guys all talk to each other, sending serial data back and forth. Transponder, radio, 430, and audio panel, all interchange analog and digital data with each other. Also, data being sent out to the two OBS VOR heads. All right, so let's stop here. Next week, we're going to talk about avionics installations. So for the week, you have to start preparing yourself. I truly have to tell you, the worst job you could do on an airplane is under the panel. It's a nightmare. And it's one of the reasons why the under panel is usually so terrible, so messy. Because people just don't want to spend very much time all tied up and stuffed in there, taking all the old wires out and getting all that crap out of there that shouldn't be in there anymore. Get it all out of there and then do whatever new installations you're supposed to do. I kid you not, I still have permanent spinal injuries from some of the jobs I've done. And I can tell you, I know of at least one very horrible F-15 accident that was partly a function of that. General Dynamics was supposed to design, but the spec for the airplane was the elevator tube, push-pull tube, and the rudder push-pull tube, control tubes that went to the back. We're supposed to have different size fittings on either end. The end bearings fittings are supposed to be different size, so you couldn't get them swapped. Okay. The installation required an access panel pulled out, get up and work behind your head because your arms couldn't bend the other way. So you had to work backwards, putting these things together. General Dynamics didn't make the fittings different. Once they figured out that was a problem, they sent information out to all the Air Force bases. That information never made it to the two mechanics. Okay, and they know exactly where it stopped. They had it all documented. A whole bunch of lawyers had it all documented. Well, the two mechanics working on it, they got the two swapped. So you pull back and the rudders go. Okay, right? Pull back, rudders go, hit the rudder pedals and the elevators go like this. Okay? Now, those of you that have been in the military, what's the first thing that's going to happen to any airplane before it takes off, particularly if it's had maintenance? Pre-flight. Well, you're going to have a pre-flight, but aren't you going to have a crew chief out there? And the last thing they're going to do is take it through the controls, right? The pilot's going to go through a very standard control Crew chief did that and didn't recognize that things were completely backwards. Okay, plane takes off, pilot pulls back, it goes that way. 2 people on board were instantly killed. Fireball instantly killed. Okay, guess what the Air Force did? You know what they did. They blamed it on the 2 mechanics. Even though their lawyers had the documentation that showed that it stopped at the maintenance supervisor, the rank of the individual. They had documentation that showed it never made it to them. They documented documentation that the crew chief had done the check and misread it. So all the checks and balances were done and failed. Both of them got dishonorable discharges. One of them served some time and ended up committing suicide in prison. Okay. It's just like, now, obviously, the Air Force needs to be spanked over that one big time. But the end of the day was, part of the problem was doing this, working behind in an area that you couldn't physically see, working backwards, okay? The rods being long enough that you didn't realize the angle had shifted. You know, a number of things. Try doing that with a bunch of little bitty number 24 wires that are all white. Okay, because some bonehead wired this thing and didn't leave a long enough pigtail service lead to get the thing out so you could actually see it and have it in your face. So I've got, yeah, I have to tell you, this is very, very painful. And planes are not designed for mechanics, are they? No. I've long said the engineer's greatest capability is to take an oil filter, hold it in space, and build an airplane around it such that you can't even see that oil filter, much less get to it or get it out. Even though that's the thing you have to change the most, right? Kind of like my wife in the can opener. I have no idea why the can opener has to be in the hardest to get to drawer. Like the thing you use the most. All right, let's quit here.